Hello, welcome back to Flipped. Today we're on chemical reactions and we'll be focusing on collision theory. Before we get into that, there are a few factors that affect the speed of reaction, which we have talked about in the previous video. Speed of reaction is basically how fast or slow a reaction will proceed in a given setting, in a given system. So there are 5 factors that actually affect this speed of reaction. First is the concentration of reactants of reaction, of the reactants themselves. Next is pressure, and there's temperature, particle size of the reactants, whether they are big or small, and the presence of catalysts. So we'll go into each of them in detail in the next video. But to actually answer all these factors, to actually take into account all these factors, there's something we need to know, and that's called the collision theory, which we'll get into right now. Basically, the collision theory explains how the reaction takes place. For a reaction to take place, reactants need to collide with one another, and hence the name collision theory. Because collision, it's needed here. Basically, you can imagine 2 marbles striking each other. That's called collision. But the thing is, not all collisions will lead to reaction. Only collision, there are 2 factors here, with the correct particles, let me just underline this for you, correct particles and the correct amount of activation energy can lead to reaction. So it's saying that you cannot just put 2 particles and just knock them together, and you will get reactions. No, you need the correct particles and the correct amount of energy to actually kickstart this reaction. Let me show you 3 scenarios in which this can occur. First one, scenario 1, you can see that I have A particle and B particles here. A here, B here. So you can see that only the B particles are colliding. So B and B will not react, right? For example, if you put say 2 copper atoms, when they strike each other, they won't react. And that's why there's no reaction in this scenario. This makes sense, because we need opposing, we need different elements, different substances to react with each other. They don't react with their own. So this one is out. Scenario 1 will not lead to reaction. What about scenario 2? We see that it's the same. We have A and B particles, but in this case, A and B are colliding. Yes, that's what we want, right? We want A and B to collide with each other. But the thing is that there's not enough, not enough activation energy. So even though A and B, they are supposed to collide with each other and react, but they do not possess enough energy for that to happen. And that will result in no reaction as well. Finally, there's this third scenario in which A and B, they strike each other, they collide, and with enough activation energy, and this will result in a reaction occurring. And this is what we want. We want the correct particles, A with B, for example, and the correct amount of activation energy. Cannot be too much or cannot be too little. Scenario 3 will be perfect. Alright, so you can see that, why don't we just put, you just knock A and B together? That will result in 100% reaction, right? The answer is no, because reactants move randomly. Because they are so small, they move by diffusion and other processes that you cannot really control each of them to collide with each other. So everything is by chance. And so to increase this speed of reaction, we have to increase this chance. This makes sense, right? So how can we increase this speed of reaction? There are 2 ways. We have to increase the chance for particles to collide. We have to make sure that there's the chance of them hitting each other is very high. For example, if we put them, so I have pink particles here and red particles here. They are significantly far away. But what if I put them very, very close to each other? For example, like this. You can see that yes, they'll almost certainly collide with each other because they are very close to each other. And that's why we are saying to increase the chances for the particles to meet and hence collide. That makes sense. Next one, we have to increase the chances, by having the particles with enough activation energy. As we discussed before, even if A and B were to collide, but they have insufficient energy, no reaction will take place. So not only we have to have the correct particles reacting, we also have to give them enough activation energy. And this is where we will talk about the 5 factors which will affect this speed of reaction. We will talk about them in the next video.